the word similarity data sets are hand-picked word pairs chosen to contain a range of different levels of word similarity. By only assessing model similarity on these word pairs, the correlations between the models may be inflated. So to provide an alternative assessment of the similarity of the three models, 1 million random word pairs were generated, and I think this is the most interesting part of the results. A brief conclusion of the first step. This suggests that while DU and UD are moderately correlated to each other, they do offer quite distinct similarity patterns when random semantic similarity is considered, and both are relatively distinct from the WW model. Here is the assessment, the test. For the test, the target word is the niche, and you need to choose the most similar word in the following options. One word is similar to the target word. And what the process, the mechanism needs to do, the model needs to do, is to look at their data set and to find the right answer. And we could say we give each model 80 questions, and then we get a result. Four options, so the chance is 25%, and both of the newly proposed models are above chance, suggesting they are capturing semantic information but have worse performance than the WW model. Analysis uses word similarity data will elucidate the performance of the different models and determine if the socially based representation types account for unique variance in this data. And in evaluating models of word similarity, it is very common to take the Spearman correlation between the data and the model similarity values. It's Peer. Now here is Spearman correlation coefficient of the proposed distributional models to the 5 word similarity data sets, and also it conducts the it calculates the Pearson correlation coefficients of the distributional models here. So that both of the socially based models achieve significant levels of correlations using the combined transformation. So here is a combined transformation part, and with the DU model achieving a similar average level fit as the WW model when a Pearson correlation is used. This suggests that using the socially based features, word meanings can still be captured. And these tables also show that the advantages of the JN and DOA transformations of the WW model replicate the findings of many researchers like Joyce in 2019, where the JN and the DOA transformation both provide major improvements over the transformed matrix. The DU model, the DOA transformation performed relatively better than the GN transformation compared to the WW model, using both the Pearson and the Spearman correlation. And these two kinds of correlation verifies the same thing. The UD model showed an opposite pattern when using a Pearson correlation where the GN transformation performs better than the DOA transformation, and the two transformations had roughly similar performance level when using the Spearman correlation. Representation types and transformations suggesting that the distributional properties of a representation impact the utility of the different matrix transformations, but for all three models across the two correlation types, the combined transformation offers the best performance level, consistent with the result of the one researchers that have mentioned in the author's literature review part. In order to determine if the UD and the DO account for any unique variance in the word similarity data, so regression analysis was employed in this research. Now here is a table of amount of unique variance of each model accounts for in the different word similarity data set. The analysis calculates the amount of unique variance that each variable accounts for in the different word similarity data sets. And it shows that both the WW and the DU models account for significant level of variance across all data sets, while the UD model accounts for significant variance in three of the data sets. The three with the largest sample sizes, which may suggest that there may not be enough data contained in the other data sets to find a significant signature of the model. Both the WW and DU model accounted for considerable amounts of unique variance, with the WW model accounting for slightly more variance on average than the DU model. And this suggests that DU model is capturing a unique component of word similarity. There is considerable variability in the amount of variance that different variables account for, likely due to differences in sample size of the different data sets and different word pairs that are used. We'll exclude the UD model in the calculation of unique variance, given that it counted for the least amount of unique variance of the three proposed models. The table shows that the exclusion of the UD model did not cause a major change in variance accounted for. In conclusion, the WW model still accounted for slightly more average variance compared to the DU model, and the DU model accounted for the most variance in three of the five data sets. So both the WW and DU model account for significant variance in the word similarity data set, signaling that these offer complementary sources of information about the meaning of words. And this suggests that the communicative patterns that the DU model encodes provides a unique measure of word similarity, with standard distributional models that learn only from word-to-word co-occurrence patterns and do not encode in the representations. Further explore differences in the representations of the WW and DU model. In this table, table 7, it contains the ranked nearest neighbors to 4 words for both model types. And this table shows that there is a different pattern of semantic neighborhoods for these words, with the WW representation tending to be similar to other semantic category numbers and different types of bird. Part of the result is feature strengths. The figure 3 contains a histogram of the feature strength models for the DU model, and this figure only contains the proportions of occurrence for z-scores from -0.4 to 0.4, and the vast majority of feature values fall between these criteria. And this figure shows that most feature addresses are below 0, which signals that the positive semantic features of a word provide most of the distinctive features for the meaning of a word. A brief conclusion here, and the success of distributional models of semantics demonstrates the systematic connection between word co-occurrence statistics and the word meanings that people have acquired. However, the use of language is not separate from the context in which it occurs. The context that language is used in are multifaceted and include social and communicative information. So in methodology part, we have talked about not only the word model that calculates the word co-occurrence frequency. We also talk about DU and the UD model, that is socially based models. We considered the context and environment language are used in. And next, the results reported here demonstrate that a model encompasses the communication patterns of how individuals use words across discourses, allows for unique measures of word similarity to be derived, signifying the usefulness of integrating alternative information sources into distributional models of semantics. And also in this research, it's not only one kind of models are used in distributional models. They use three models that they can capture the same information, but they also could capture different information that other models could not. So the integration of the three models are important and more useful than only use one kind of models. And this is the end of my presentation. And in this paper, there are some knowledge I have not learned before. So maybe in presenting this paper, I have met some difficulties and something I'm not very clear about it. So if you have any suggestions, you could send me an email about this paper. And bye bye. See you next week.